What should our optimal buffer size be? Can we provide ourselves a little more margin for error? First, we can start by just taking a quick look at how our buffers are currently performing by charting their performance. This is a very straightforward process. Under the User Interface tab of the toolbox, I'll select the chart and place 2 in our worksheet by holding the Control key. Next, we'll drag each of our buffers into each of the chart objects. We can now right-click and select Show Display Window. Finally, we'll run the simulation and look at our results. This shows me that our first buffer is spending most of its time with only one part, while our second buffer is spending most of its time fully loaded. So what is the optimal buffer size? For this, we will use the Experiment Manager to help us determine what we should size our buffers. Let's close these charts and get back to our Tools tab in the toolbox, where we'll select the Experiment Manager and drop it into our worksheet. Next, we can drag and drop each of our buffers into the Experiment Manager, selecting Capacity as the parameter that we want to track as our input for the Experiment Manager. Now I can double-click on the Experiment Manager and define the output value that we want to study. In this case, we will use our drain. We select Output Values. Then we can drag our drain into the first line here. Our objects have many parameters, so to make sure we are studying the throughput of the drain, we can open the drain, select Type Statistics, then select the Help icon here and click on Throughput. Notice that it provides us with the SimTalk value. After we close our drain dialog, we can add .StatDeleted to our output value. It is time to adjust a few more things to help our experiment run more manageable for our demo. Let's change the observations per experiment to 3. This means that we will run 3 simulations for each experiment that we define. We already have a confidence level of 90% set, which is good. Finally, we need to define some characteristics for the Experiment Manager so that it can create our experiment runs. To do this, we'll select Tools from the Experiment Manager window and then Multi-Level Experimental Design. Now we get to define the upper and lower limits for our buffer experiment and the step increment to use. For this session, we'll start at 5 for our lower limit, 50 for our upper limit, and we'll use a step increment of 5. Click Apply. Plant Simulation will now generate an experiment table for us automatically. We click OK here and OK in the Manager dialog box, and we should be ready to run. Right-click the Experiment Manager and select Start. As the Experiment Manager runs, you can get a feel for the current progress by watching the clock in the middle count down. Once the Experiment Manager finishes processing, it will generate this HTML report screen. Here you can view all of the results. For example, we can click on Output Values to see how many parts were created as a result of each of our experiments. As we can see, at the lower buffer size values in our first experiments, we only achieved a throughput of 982 parts, which is below our target throughput. As we scroll down, we start to see throughput improve and eventually we reach a plateau around experiment 66. Another way to look at these results would be to select the interesting output values from our statistical evaluations. Here the results are charted based upon confidence intervals and provide us with a graphical view that can be easier to understand. So what was our optimal buffer size? If we go back to our output values, we can see that we achieved our highest throughput at around experiment 39, and again as we plateau at experiment 48. If we check our input values and scroll to experiment 39, we will see that the size of our first buffer is 20 and our second is 45. Likewise, experiment 48 shows our first buffer at 25 and our second buffer at 40. Either of these values will provide optimal results and allow us to achieve our target throughput goals comfortably. Let's go ahead and adjust our buffer sizes to 20 and 45. Then we'll run a new simulation to check our results. To do that, we double-click each of our buffers and change the values. Now we'll reset and select Run. Double-click the drain on our third experiment, select the type statistics, and we'll see that we are now at 1,140 parts.